Professor Pelton. This is Algebra 2, Chapter 6, Section 3, Logarithms and Logarithmic Functions. Okay, so in the beginning of the chapter, we could not solve problems properly because we didn't know how to solve when the variable was in the exponent. So if it's a nice whole number answer, we can do it just using our intelligence. So if we have 2 to the x equals 8, clearly x is 3. Okay, but what if 2 to the x equals 13? Well, now we need another technique to be able to do that, which is called a logarithm. So you need to convert to logarithm form to be able to do this. It's because essentially if I do a log base 2 of 2 to the x and log base 2 of 13, that gives me x equals log base 2 of 13, which is something I can plug in the calculator using the log button. So you need to be able to go from the log format to the exponent format back and forth effectively to be able to solve problems in this chapter. So what you have to keep in mind is these can be flipped around left to right or right to left. So you can write either of these uh, backwards or forwards. So this could be x equals b to the y, and this could be log base b to the log of x base b equals y. Okay, so what's important to keep in mind is the base of the log is the base of the power. Okay, the point of the log is to get the exponent. Okay. All right, let's do some conversions back and forth to make sure you get this. Okay, so log base 2, so that means 2 is the base, 4 equals 16, right? Because the point of a log is to get the exponent, and the bases match. So this is 4 to the 0, because the point of the log is to get the exponent, equals 1. The bases must match. Log base 5, it must be a base 5. We're supposed to get 2, which is the exponent, okay? Because the point of a log is to get the exponent. All right, so base b of the log is also the base of the power. 3 equals 24 because the point of the log is to get the exponent, so log equals an exponent. So this is 3 to the y equals 7 because the bases must match, and the point of the log or the outcome of the log is the exponent itself. Okay, and notice that sometimes the log's on the left, sometimes the log's on the right. I chose as practice to write it as the outcome on the right and the power on the, but you can switch it. You can do 16 equals 2 to the fourth. It's still equivalent. Pause the video, try the student problems for yourself. Okay, so this one is 12 to the 1 equals 12. Base matches, and the outcome is the exponent. This is 1/4 to the negative 1. It's going to be careful because you need to put that in parentheses. Equals 4, right, which is the 4 right there. So this is 4 to the 8 equals x. The bases must match. That's the outcome, which is the exponent. B to the 4th equals 16. The bases must match. That's the exponent. The outcome of the log is the exponent. And 2 to the y equals 9. Okay. Okay, let's go the other way now. Now going from exponential format to the log format. So if it's a base 5, then it's log base 5. And you do of 25, and the outcome of it is the exponent. Right? The outcome is the exponent. The bases must match. So if it's base 10, this is log base 10 of 0.1. And the outcome is negative 1, because the outcome is supposed to be the exponent. So this is log base 1/4 of y equals x, because the outcome is the exponent. So this one is log base 4 of 15 equals x, which is the exponent. Notice they switched it sometimes as to which side has the exponent. That's fine, because they can switch either one of those, because this could also be 2 equals log base 5 of 25. Either one is correct. It's really a preference as to which one you'd want to do. Pause the video, try the student problem for yourself. Okay, so this one is log base 8 of 4 equals 2/3. This one is log base 6 of 1/216 equals -3. This one is log base e of 33 equals y, which we'll find out later is actually the natural log of 33 equals y. Just remember that one for later. And this one is log base b of 27 equals 3, because 3 is the exponent and the bases must match. Okay, let's go to page 2. All right, so a couple of rules you must know is the log of 1 rule. Log of 1 is always 0. It does not matter what the base is, because if I have log base b of 1 equals 0, it does not matter what I pick for b. Obviously, it has to be a positive number, right? Or not 0 also. So if I convert that to the exponent format, that's b to the 0 equals 1. What's anything to 0 power? 1. Hence why that's always true. Okay? So the other one is the cancellation rules, whether it's a log or exponent. It's the same thing either way. If I have a log base b of b to the x equals x, why does that cancel? Well, b to the x equals b to the x, right? So that's the base and the outcome if I convert the formats, which cancel and leave you with x. Okay? So log bases and exponent and power bases cancel each other, okay? Because they're inverse operations. So if we go through these, this is log base 7 of 7. So they would cancel, but it doesn't leave you with nothing because there's actually a 1 right here. So the answer is actually 1 when they cancel each other, okay? You can think about it as, right, and equals some value. We don't know what that is. You can put a question mark there if you want to, instead of an x, since there wasn't one to begin with. This equals some question mark. So 7 to the question mark equals 7 to the 1, right? This one to there, and the base and the exponent. So obviously it has to be 1. So here, that's just 0, because log of anything of 1, log base anything to 1 is 0. These cancel, leave you with 5. These cancel, leave you with 9. But this does not cancel because base 2 log does not cancel the base 2 of an exponent, because that's really 8 to the 1. It would not cancel. However, you can rewrite them because 8 is 2 to the third, which will in fact cancel and leave you with a 3. Pause the video, try the student problems. Okay, so log of 1 does not matter the base. The answer is 0. Log base 9 of 9, there must be a 1 right there, so the answer is 1. Those cancel, leave you with an 8x. Those cancel, leave you with a 17. Those don't cancel, however, log base 3 of 3 squared is the new value of 9, which does cancel, leaving you with a 2. Okay, so we're going to use that to evaluate logs also. So you can evaluate logs by hand if they work out to nice values that are rational. They don't always, but these ones will. So if I think about this, log base 4 of 64 has to equal something. So if I think about it, that's 4 to the question mark equals 64. Well, 4 to what power equals 64? Well, that's 3. Okay, well, this one equals something also. So 5 to some power equals 0.2. Okay, well, 0.2 is 2/10, right? That's 1 decimal place is tenths, right? So 5 to what power is really 1/5. So I need to flip it over, but how do you flip it over? You need a negative exponent for the question mark. That's how you reciprocate fractions, right? So next one, question mark. So this is 1/5 to the question mark equals 125. So I need to flip it over. So that's going to be negative, right? I also need to make it bigger. So 5 to what power is 125? -3. Because you think about it, 1/5 to the -3 is 5 over 1 to the third, which is 5 to the third and 1 to the third, which in fact is that. So that is our answer. All right, last one. This equals some value. So 36 to what power is 6 when I convert the format? Well, I have to get smaller, but a negative is not going to do that for me, because if I put a negative in there, that's going to give me 1 over 36. That doesn't give me 6. So a positive whole number is not going to work. A negative whole number is not going to work. What does that leave? That leaves fractions. So 36 to what power gives me 6? Well, 1/2, because that's really the square root of 36, which is 6. So the answer is 1/2. So you're either going to have positive whole numbers, negative whole numbers, or fractions. The negatives are going to flip you top to bottom or bottom to top. The fractions will make you smaller with radicals, and the whole numbers will just make you larger. Pause the video, try the student problems for yourself. Okay, so this equals some value. So 2 to some value is 32. If I think about that, what is it? It's actually 5. You can also rewrite this as log base 2 of 32 equals log base 2 of 2 to the 5th, right? Because 2 to the 5th is 32. Also cancels, still gives you a 5. So there's a variety of ways to get to it. So this is some value. So 27 to what value is 3? I need to make it smaller. I can't use a negative, that'll flip it. So it must be 1/3 for a radical, because the third root of 27 is 3. Because essentially at the end of the day, uh, 27 to the 1/3 is the third root of 27. Okay, next one. 5 to the question mark equals 1 over 125. I need to flip it over, so it has to be negative. And 5 to what power is 125? 3. Because 5 to the negative 3 is 1 over 5 cubed, which is 1 over 125. All right, last one. 3 to what power is the 7th root of 3? 3, or basically 3 to what power is, that's not a very good question mark, is 3 to the 1/7. Well, that's just going to be 1/7, right? Because you just cancel. That is the end of part 1.